Hi guys, welcome to another video of Physics 2. In this case, we are going to see free fall. That is the continuation of the motion in one dimension. Okay, so let's see this problem. It says, a construction worker drops accidentally a hammer. I'm just going to change the color of this. Okay, a hammer from the top of a building. This hits the ground at minus 73, this is important, minus 73 meters per second. So answer the following and we got two questions. How much time does the hammer take to hit the ground? And what is the height of the building? Okay, so how do we know that it's a free fall? Well, there is a keyword. This is the keyword, drops. Well, this means that construction worker didn't throw the hammer. He just let go the hammer. Okay, so that means that there is no initial velocity. That means drop equals to let go. I mean, didn't throw the object. So when we have that, we're gonna have a free fall problem. Free fall. Okay, and in a moment I'm going to explain the features of that kind of problems, but first just remember the reference system. Everything that goes up is positive and everything that goes down is negative. That's why the final velocity is negative, because the object goes down. Okay, so I'm going to make the drawing. So this is the building and the worker is here at the edge of the building. And he drops the hammer. To me, that's the hammer. Just a circle, okay? And the hammer is falling. So then hits the ground, okay? That's it. That's the hammer, okay? So let's write the data that I have. I'm gonna change the color. So to me, this is the start of the motion and this is the end of the motion. So if this is the start of the motion, that means that is the initial position and this will be the final position. So I'm gonna say that the final position is the height of the ground. So how much is the height of the ground? Well, of course, it's gonna be 0 meters. So to me, in order to do this problem, I mean, you can do it in a different way, but to me, I'm going to consider that the final position is always the ground, because that's the end of the motion. Everything will be falling from above. So the final point of the motion will be the final position or the ground. So to me, that will be 0 meters. Okay, so the initial position will be the height of the building, which I don't know. Okay, this is a question. But also I got the initial velocity. So I said that when we drop equals let go, so that's a free fall. In those cases, the initial velocity will be 0 meters per second. Always, always, always. That's kind of the feature of the free fall, okay? And also, I'm gonna have the final velocity is in the final point, okay? So this will be minus 73 meters per second, okay? Also, I got the acceleration, and the acceleration is the value of the gravity, and the gravity goes down, so that's why it's negative, minus 9.8 meters per second square, okay? So I need to find the initial position, that will be the height of the building, and also the time, okay? The time that took the hammer to hit the ground, okay? So let's change the screen. Okay, over here I'm gonna write data. The data, I mean, I'm gonna write it again. So initial velocity is 0 meters per second. Final velocity is minus 73 meters per second. The acceleration is the value of the gravity, that is minus 9.8 meters per second square. Okay. The final position is 0 meters because that's the ground level. Initial position is the height of the building. I don't know. Also, I don't know the time. And that's the data that I have. Okay. So then, well, then let's write the equations that I know. The first equation, acceleration, equals final velocity minus initial velocity over time. And the other equation is final position equals initial position plus the initial velocity that multiplies the time plus the acceleration times square over 2. Okay. So with another color, I'm gonna cross and check mark what I have and what I don't have. Acceleration, yes, I have acceleration. Final velocity, initial velocity, yes. Time, I don't have time. So from this equation, I'm going to find the value of the time. But before I do, I'm gonna cancel initial velocity because initial velocity is 0, so I cancel it. So I'm gonna write the equation, acceleration equals final velocity over time, and from this equation I'm going to isolate time. So time equals final velocity over acceleration, just because time goes this way and acceleration goes that way. Okay, so this is gonna be minus 73 meters per second over the value of the acceleration, that is the gravity, that is minus 9.8 meters per second square. Okay, so meters is going to be cancelled with meters, second with this second, and the units are going to be seconds. So time equals, let's get the calculator that I got over here. Okay, so fraction minus 73 over minus 9.8 equals, it's going to be positive because negative over negative is positive, and this is the value of the time. And if you see, it's an infinite value, and I'm going to need it in order to find the initial position, that is the height of the building. So I'm going to save this value in the memory A of the calculator. Okay, Shift STO and A. So this tells me that I already saved the value. So let's write the answer. 7.4489 seconds. This value is saved in the memory A of the calculator, and I'm gonna circle this with red because that is one of the answers of the problem. Okay, how much time? This is the time. And then let's go to the other equation. Okay, final position, do I have it? Yes. Initial position, no. Initial velocity, yes. The time, yes. The acceleration, is the value of the gravity, and the time, yes. Okay, so with this equation, I'm going to find the value of the height of the building. Okay, so I'm gonna cancel the final position because it's 0, and also the initial velocity because the initial velocity is 0, and also time because it's going to be multiplied. So 0 equals initial position plus the acceleration times square over 2. Okay, so I'm gonna move the initial position to the left, and it will be minus initial position equals acceleration times square over 2. But this negative, I'm gonna move it to the other side. Okay, so this will be positive and this will become negative. And if you want, you can circle this equation because that is the height in free fall. Okay, but only in free fall. In this In this section, we're going to see 4 types of motion. That is going to be free fall, vertical throw, horizontal throw, and parabolic throw. Okay, so this equation we are going to use it here in free fall. Okay, well, let's substitute the values. Initial position equals negative, parentheses, the value of the acceleration is minus 9.8 meters per second square, times the time, 7.44 seconds, raised to the square, over 2. Okay, so let's do it in the calculator. Fraction, negative, parentheses, minus 9.8, that multiplies the value of the time, and the value of the time I already saved it in the memory A. It's going to be raised to the square over 2. And let's see how much is that. Yes, that is the height of the building, 271.8877 meters. Now, to be honest, I'm not sure if there is a building with that height. I don't know if in Chicago or New York. I mean, I'm not sure. I just invented this problem. I hope that that measure of height is possible. So this is the first problem of free fall, and if you see, we got the same equations. The only thing that changed were the letters. In this case, we are not using X as position, we're using Y because the motion is in the vertical axis. Okay, so we'll see you again, guys, in the next video. Bye bye.